My name is Marcus Lynn Francis Davis, advancing basis participant, 2024 baseball winter meetings, Dallas, Texas. Fielding the bunter situation, is there any communication? Embarks upon the gameplay of the bunter and defensive arrears that are critical communication within the situation during gameplay. The batter steps into the box at exactly 15 seconds countdown. Umpire and catcher wait for the pitch. The batter is a bunter. The defense recognizes the bunt. The pitcher delivers. The bunter bunts a soft pop fly between the pitcher, shortstop, and second baseman. Is there an infield fly rule, or is the bunter safe? This is an unfamiliar situation, being a defensive player within the shift and moving into the less of a shift. Fielding the bunt situation, is there any communication? Embarks on the small ball. Often called that within baseball, with increased speeds and time-induced gameplay, the situation is the bunter must be critical communication between all player communications defensively. Player A, catcher, player B, pitcher, player C, first base, player D, third base, player E, second base, player F, shortstop, respectively. Lack of communication between each key player in the situation is crucial to the defensive effort to make a play on the bunter. The areas of coverage, according to the field size, is an important metric for each defensive player as individual teammates. Rule 2.00 defines the infield fly as a fair fly ball, not including a line drive or bunt, which can be caught by an infielder with ordinary effort when first and second base or first, second, and third base are occupied before two are out. The rule book definition of infield fly says the umpire shall immediately declare infield fly for the benefit of the runners. However, sometimes they do not, as in the 2008 World Series game. There may be doubt as to whether the ball was catchable by an infielder with ordinary effort. As changes have been implemented within the game of baseball, such as increased size of the bases, the two biggest MLB rule changes within 2023 season are pitch clock and the elimination of the defensive shift. Fielding the bunter situation, is there any communication, utilizes two case studies to show the importance of the metrics for area under the curve. This area has distinct arrears of communication for the defense as seen in the picture. Each position player has location-specific arrears requiring defensive communication that is critical during gameplay. Case study 1 for the bunting against the shift. When an MLB player bunts to beat the defensive shift, who really wins, the offense or the defense? Data analysis and statistical probability tools are used to answer this important question. This case study using data science to analyze if MLB players should bunt to beat the shift by Andrew Finnicle, published in Sports Analytics in 2020. To bunt or not to bunt? That is the question. The inconclusive question, in an era of pitchers no longer hitting, is the valuability of the position player more for a sacrifice bunt and situational hitting and or defensive ability in the bunt situation. Case study 2 for seam shifted wake, SSW, has spin rate as the topic, attempts to explain non-Magnus and drag movement caused by seams or the baseball, or in other words, movement that is not caused by the spin of the baseball. We're talking about seam shifted wake wrong by Michael Agetto in 2022. The term SSW, coined by Andrew Smith, attempts to explain late movement, often referred to by fans and scouts alike. This research proposal, fielding the bunter situation, is there any communication, depicts two case studies as the major research to clearly explain both dribblers and bunts alike. The weight force will be held constant for both situations side of the infield. Fielding the bunter situation is there any communication develops an essential model for the probabilities of the infield grass. The model gives the infield situational positioning to define area under the curve for the defensive bunt situation with the defensive bunt situation with the distance according to the field dimensions as seen with official baseball playing field. Situations for defensive communication are depicted by red diamond. Each has a location as area under the curve, with location-specific designation within the grass in the infield, wherein each location designates a situation for defensive communication. The dimensions of the entire area under the curve will be covered by the equation. Behind the mound is the area under the curve held constant within all bunt situation for the defensive coverage within 90 feet square with red diamond. This experimental study depicts some scenarios as scenario within area under the curve as future research within the actual data within the individual games depict more conclusive data to present that gives details on the bunter defensive situation. The actual data variables will consist of the data presented as an ideal case scenario for each bunter situation according to the area under the curve. The equations within area under the curve are only experimental with small case study of data points as seen within MLB games from YouTube videos for the scenarios as data sample to predict area under the curve in real-time data points utilizing the sample data variables for the pitcher, pitch type, pitch speed, spin rate, and batter bunter, exit velocity, launch angle, hit distance, as given through sample from April 2023 YouTube video footage and data sets. Note, these data sites as video footage can be seen on LinkedIn. Utilizing Rapsodo would enhance the knowledge of the scenario for the study of the bunter defensive situation. The bunter defensive positioning is given, and with further research of the pitcher data and batter bunter data is foreseen variables that can coincide with area under the curve to present an actual perspective from the infield positioning of the area under the curve as defense and bunter envisions the placement of the ball according to the field's dimensioning within the infield. Equation for the area under the curve known as arrears by definition as the constant for the area under the curve. Standard formula for calculation arrears squared times C equals 90 square feet according to infield dimensions. By derivative of the equation, we derive 2 arrears plus 1 equals square root of 90 feet squared, whereas theorem